Welcome everyone. In this video I will talk about solution of Euler-Cauchy form of linear differential equation. So let's start. First of all, let us understand what do I mean by Euler-Cauchy form. So Euler-Cauchy equation is the equation which appears in this form. Which form? If you look at the yn, that is the nth order derivative of y, it is multiplied by x to the power n. If you look at this term, which is n minus 1th order derivative of y, it is multiplied by x to the power n minus 1. If you look at this term, that is the first order derivative of y, it is multiplied by first power, means x to the power 1. If you look at y, means no derivative of y, so it is multiplied by no power of x, and that is equal to the right hand side, right? And this a0, a1 and all these constants are real constant. Okay, now if you look at the examples here, this is in Euler-Cauchy form because here y double dash is multiplied by x square, means the second order derivative of y is multiplied by second power of x. First order derivative of y is multiplied by first power of x, and this is y, means no derivative of y is multiplied by no power of x, means x to the power 0. So that is just the constant term. Similarly, you can see that this is also in Euler-Cauchy form, right? This linear differential equation is also in Euler-Cauchy form. So all these are examples of differential equation in Euler-Cauchy form. If I write one example which is a not example, suppose I write something like x cube y triple dash third order derivative of y plus 2x y double dash plus 7y is equal to 0. So this is not in Euler-Cauchy form because if you look at this term, it is a second order derivative of y, but it is multiplied by the first power of x, right? So I hope you are clear about how to identify the differential equation, that whether it is in Euler-Cauchy form or not. Now let us talk about the process of solution. So process of solution, it can be done directly also without going into the detail, but just to make it clear, I am explaining and then I will be doing a lot of problem solving. So first understand this and then you can see the problems as well. So what we do, first step is to reduce the given differential equation which is in Euler-Cauchy form into a differential equation which is with constant coefficient. So to do that, we make a substitution, that is z is equal to log x, right? Actually, if you look at the original equation, if I consider the original equation in which the y is the dependent variable and x is the independent variable, now I am making a substitution, z is equal to log x or x is equal to e to the power z, and I am trying to change the original equation into a new form where y is the dependent variable, and not x, rather z is the independent variable. So by this substitution we can do that transformation. So how does it work? Suppose we have the differential coefficient, that is dy by dx, and in Euler-Cauchy form it is appearing like what? It is appearing like x dy by dx, or we can say that it is appearing like x y dash, that is the more popular notation. So I am trying to change dy by dx in terms of dy by dz. So if I have to differentiate y with respect to x, I can differentiate y with respect to z first, and then we can differentiate z with respect to x. Now I have used the transformation, that is z is equal to log x. So dz by dx will be what? It will be 1 by x dy by dz. Now you can see here that this expression, if I may call it equation number 1, so if I multiply here x in the left hand side, I will get x dy by dx is equal to dy by dz. So basically whenever we have in the expression x y dash or x dy by dx, I will replace it by dy. Now this d that I have used now stands for this d that stands for d by dz, because the new independent variable is the variable z. So dy by dz can be written as dy, capital dy, where capital D now stands for d by dz, right? Now the next thing is that what if we have the expression like d2y by dx square, because the next kind of term that we may encounter is x square, that is d2y by dx square, or I can say that x square y double dash. So how to reduce that term into a term with constant coefficient? So to do that, let us look at this expression. So d2y by dx square can be seen as d by dx of dy by dx, right? This is, I think, clear to everyone that second order derivative of y with respect to x can be written like this, which in turn can be written like d by dx. And what is dy by dx? dy by dx from the equation 1 can be seen as 1 by x into dy by dz, right? And on this I can apply the product rule. What is the product rule? So this is the first function 1 by x, and this is the second function. So I can write 1 by x d by dx of the second function, that is dy by dz, and plus second function is dy by dz and d by dx of 1 by x. Let me actually write it here in the bottom, because this may create visibility problem. And let me repeat the whole argument again. So what I am saying that this d2y by dx square can be seen like what? This d2y by dx square. Now I am going to apply the product rule here. So there are two functions, first function, second function. So I write the first function 1 by x, derivative of the second function, that is d by dx of dy by dz, and the second function again is dy by dz and derivative of the first function, that is d by dx of 1 by x. Now here is the important point. The important point is that this expression can be further seen as d2y by dx square, and listen this very carefully. 1 by x, I have dy by dz and I want to differentiate it with respect to x, but our aim is to change the differential equation in terms of dy by dz, where y is the dependent and z is the independent variable. So I want the differential coefficient in terms of z. So in place of differentiating this thing with respect to x, we can differentiate this with respect to z. So d by dz of dy by dz, and as using chain rule I have to write dz by dx, right? So for this term which I underline, I have written this expression, and d by dx of 1 by x we know is minus 1 by x square into dy by dz. Okay, now what is this? This is d by dz of dy by dz, right? So d by dz of dy by dz will give me what? It will give me d2y by dz square, and dz by dx, so this dz by dx, z is log x, so this term will give me 1 by x, and we also have 1 by x here. So can I write this term will give me 1 by x, we already have 1 by x here, so I can write it 1 by x square, and this expression can be written as d2y by dz square, and here we have minus 1 by x square into dy by dz. So finally, if you look at this expression, from this 1 by x square can be taken common, and we can multiply it in the left hand side. So in the left hand side I will get x square d2y by dx square, and here in the right hand side I am getting d2y by dz square minus dy by dz. Now as I have already used the notation capital D for d by dz, we can clearly see that d square now will stand for d2 by dz square, and dq will stand for d3 by dz cube, means third order derivative with respect to z. So this expression here, d2y by dz square, can be written as d square y minus dy by dz I already have used, that is dy. So this can be written as d common into d minus 1 of y. So now we are getting an expression, and this is something that we need to be careful about. So this is the first expression that I got, that wherever I will get xy dash, I will replace it by dy. And if you look at this expression, I am moving to the next page. So wherever I will get x square y double dash, as you can see here, this is nothing but, what is this? This term is nothing but x square y double dash, and this would be replaced by d into d minus 1y. So this will be replaced by d into d minus 1y. So we have replaced xy dash by dy, x square y double dash by this. Similarly, if you continue this process, you can replace x cube y triple dash, and I hope you are smart enough to guess. So this will be d into d minus 1 into d minus 2y. And I hope you have got the drift now. So the x4 y4, the fourth order derivative, can be replaced by d into d minus 1 into d minus 2 into d minus 3 and y, and so on. So this process will work like this, right? So to understand this, I am going to take a few examples, and the first example is already appearing in front of you. So suppose they ask that find the general solution for this linear differential equation. First of all, I hope you are clear that Euler-Cauchy form of differential equation is a differential equation with variable coefficient. So how to solve it? So to solve it, we make the transformation that let z is equal to log of x, or x is equal to e to the power z, and we already have used that. Now whenever I will write d, this will stands for d by dz. So under this transformation, this equation, the above equation reduces to it reduces to what? For x square y double dash, I will write d into d minus 1y, plus for 2xy dash I will write dy, and minus 2y is equal to 0. I have used this transformation. Now this can be seen as d square minus d plus d minus 2y is equal to 0. So what did I get here? I hope everything is correct. Here I made a small mistake, so I replaced d into d minus 1y, and actually xy dash I replaced by dy, but it is 2xy dash, so it is 2dy, right? So d square minus d, and here it is 2d. So I will get what? I will get d square plus d minus 2y is equal to 0, and this is a linear differential equation with constant coefficient, and we already know the process of solving it. So to solve it, what we write? We write the auxiliary equation is. So what is the auxiliary equation? Auxiliary equation is m square plus m minus 2 is equal to 0. So only thing that we have to do here is this, and rest of the things we already know. We already have seen in the previous video that how to solve this kind of linear differential equation. So I will write m square plus 2m minus m minus 2 is equal to 0. So this will give me what? Here I can take m common, m plus 2. Here I can take minus 1 common, that is m plus 2 is equal to 0. So this will give me m plus 2 into m minus 1 is equal to 0. So we have got two roots which are real and distinct, that is minus 2 and 1. So what is the general solution? General solution is c1 e to the power, and here a lot of people make mistake. Now this differential equation is a differential equation in which y is the dependent variable and z is the independent variable. So we should not write c1 e to the power minus 2x, but rather we should write c1 e to the power minus 2z plus c2 e to the power z. But original equation was in terms of x and y, so we can't leave our answer like this. We have to transform it in terms of x only. So I will write c1 e to the power minus 2 log x, z is equal to log x, plus c1 e to the power z is equal to log x. So what I get? I get y is equal to x to the power minus 2. So I hope you understand this, the basic thing, that c1 e to the power minus 2 log x can be seen as e to the power log x to the power minus 2, and e to the power log x to the power minus 2 is x to the power minus 2, so that is 1 by x square. You don't have to write all this. This is, I think, very obvious. So it will become c1 by x square, and y will become, this term will become just x, so c2x. So this is the general solution corresponding to this linear differential equation which were appearing in Euler-Cauchy form. So I hope the process is clear and you have understood the details as well. Now let us quickly solve few more problems so that the process becomes very clear. So it is also, you can clearly see, is in Euler-Cauchy form. And now we are clear about the process, so I am going to write directly that I will make the substitution z is equal to log x, or x is equal to e to the power z, and I will specify that now the capital D will stands for d by dz. So the above equation reduces to what? So the above equation reduces to, you can write that the above equation reduces to 2d into d minus 1 y plus dy minus 6y is equal to 0. So you can write here 2d square minus 2d plus d minus 6y is equal to 0. So you will get what? You will get 2d square minus d minus 6y is equal to 0. So this is a linear differential equation with constant coefficient, and you know the process. So what is the process? The auxiliary equation is 2m square minus m minus 6 is equal to 0. We need to factorize this, so I can write 2m square and how it will be, like minus 4m plus 3m minus 6 is equal to 0. I hope it is clear. Minus 12m square, yeah. So now I can take 2m common and I will get m minus 2. From here I can take 3 common, I will get m minus 2 is equal to 0. So I can take m minus 2 common and I will get 2m plus 3 is equal to 0. So m is equal to 2 and minus 3 by 2. So what will be the general solution? I am writing here because there is no space. So the general solution will be y is equal to c1 e to the power 2z, again don't make the mistake of writing 2x, and c2 e to the power minus 3 by 2 z. But z you have taken log x, so you have to write the log x here. So this means y becomes c1 e to the power 2 log x and plus c2 e to the power minus 3 by 2 log x, right? So I hope now you are clear that how the log works. So it will be c1 x square and it will be c2 x to the power minus 3 by 2. So basically it will become by x to the power 3 by 2, so that is x root x. Okay, so this is the general solution. So 2 problems done. Let us move to the third problem. Now in this first 2 problems were of homogeneous kind, so this problem I have taken is of non-homogeneous kind, because the process remains same. Only thing is that you have to make the appropriate transformation. So clearly you can see that this is also in Euler-Cauchy form, x square y double dash x y dash minus 3y is equal to x cube. So what we do, we make the transformation, that is z is equal to log x, or x is equal to e to the power z, and I will write the capital D now is defined as d by dz. So I will be using the notation capital X for d by dz. So the above equation reduces to 2 times d into d minus 1 y plus 3 dy minus 3y is equal to, and why I was writing that it should be clear that x cube, so it will be e to the power z cube means e to the power 3z. So this expression we have to simplify, so it will become 2d square minus 2d plus 3d minus 3y is equal to e to the power 3z. So here it will become like 2d square plus d minus 3y is equal to e to the power 3z. So this is a non-homogeneous linear differential equation, so y should be written as complementary function plus particular integral. To find the complementary function, we write the auxiliary equation. So the auxiliary equation is 2m square plus m minus 3 is equal to 0. We need to get the roots, so it will be like 2m square how much plus 3m minus 2m minus 3 is equal to 0. I hope it is correct. Minus 6m square minus 6m square, yes. So here I can take m common, so I will get 2m plus 3, and here I can take minus 1 common, so I will get 2m plus 3 is equal to 0. So I will get 2m plus 3 into m minus 1 is equal to 0. So m is equal to minus 3 by 2 and 1. Now I am continuing in this side. I don't want to go to the next page because I have to work harder to look at this. So now if I write the next step, so what is the complementary function? Complementary function is c1 e to the power minus 3 by 2z plus c2 e to the power z, and I think now you are smart enough to see that it will become c1 e to the power minus, so it will become c1 by x root x and plus c2 x e to the power z. Z is log x, and it is x log x, so x to the power minus 3 by 2, so that is x log x. Now we also have to find pi. So what is pi? Pi will be 1 by 2d square plus d minus 3, and that we have to operate on e to the power 3z. See, the idea is that if you have understood the operator method clearly, and if you have watched the previous video, after this stage we already have done sufficient problems, so there is nothing new in this. We already know all these things, but just to practice problems I am doing this. So now we know how to do this operator. So we can write 1 by, and in place of d you write 3, so 2 into 3 square plus 3 minus 3 e to the power 3z. So what I got, 3 and 3 cancel, 3 square is 9 into 2 18, so I will get 1 by 18 e to the power 3z, which is basically 1 by 18, and e to the power 3z is nothing but x cube, right? E to the power 3 log x, and log x actually log x cube, and e and log are inverse, so 1 by 18 log x cube. So what is y? Y is equal to the general solution, that is c1 by x root x plus c2x plus 1 by 18 x cube. Okay, so we are done with this problem also. I actually had left a page here so that we can use, but it was fine, I did in that page only. Now let us quickly do this problem as well. Now how to solve this? So again, without any confusion, we can write that let make the transformation, that is z is equal to log x, or x is equal to e to the power z, and the capital D stands now for d by dz. So the above equation reduces to, now it has become a habit, I will write the same thing. So the above equation reduces to what? We already have shown that x square y double dash should be replaced by d into d minus 1 y plus 5xy dash will become 5d plus 5dy, sorry, and plus 3y is equal to log x, so we are substituting z for that, so I will write z. Now simplify this, so it is d square minus d plus 5d plus 3y is equal to z. Now this will become d square plus 4d plus 3y is equal to z. Now we have to solve it further. So what is this equation? This is a linear differential equation with constant coefficient. So the general solution is y is equal to cf plus pi. To find cf, we write the auxiliary equation. So the auxiliary equation is What is this auxiliary equation? M square plus 4m plus 3 is equal to 0. So I factorize it. I will write m square plus 3m plus m plus 3 is equal to 0. So here I will take m common. I will write m plus 3. I will take 1 common. I will write m plus 3. We are very smart. We can do it very easily. So m plus 3 into m plus 1 is equal to 0. So m is equal to minus 3 and minus 1. Continuing in this side, let me change color. Make it look colorful. Let's play holy. So what is the complementary function? So complementary function will be c1 e to the power minus 3 log x and c2 e to the power minus log x. I hope you got. I actually, in place of z, I already have written log x, because I will write c1 e to the power minus 3z and minus z. So for saving one step, so I will write c1 by x cube plus c2 by x. So this is our complementary function part. Now the next thing we have to find is the particular integral part. So particular integral will be 1 by d square plus 4d plus 3, and that we have to apply on what? We have to apply on z. So how do you solve this kind of problem? Do you remember? To solve this kind of problem, we already have done many such problem, but anyway, I am solving it. So I take the lowest degree term common, that is 3 common, and I write it 1 plus 4 by 3d plus d square by 3, and that we are going to apply on z. So this I will write 1 by 3 and 1 plus this 4 by 3d plus d square by 3, right, and whole to the power minus 1, and that we apply on z. One thing, ladies and gentlemen, it is very clear that I just want the d term, up to d term, because d square term will also not be needed, because if you have to operate d square on z, it will become 0. Z is a degree 1 term. So just for our understanding, I can write 1 by 3, 1 minus, and this whole thing. So I will write minus 4 by 3d and minus d square by 3. If I write the square of this term, so it is a plus b, so a square will be d square, then d to the power 4 and 2ab. So that we don't need. So I'm not writing the other term. Basically there will be other terms as well, but no need to write them, right? You can just put dot dot dot, so highlight, so everyone understand that actually you mean that the other terms will also be there, but it is not needed. So 1 by 3 and 1 into z will become z, and minus 4 by 3, and d of z will become 1, and then d square of this will become 0. So what did I get? I get z by 3 and minus 4 by 9. So this is what we have got as our pi. So z was what? Z was log x, so we got 1 by 3 log x minus 4 by 9. Since we don't have the space, I am not writing the y is equal to this thing plus this thing, right? If you wish, you can write it, and certainly you should write it, because we don't have a space. We have to move to the next page, but I hope you got. So the general solution will be y is equal to this c1 by x cube plus c2 by x and plus 1 by 3 log x minus 4 by 9. We have left the space, but since we managed in just one page, and there is no need to move to the next. Let us do this next question and wind up the discussion, right? Problem solving, I have done so many problems so that everyone is very clear about the process, right? Otherwise the concept is just one simple thing, that replace xy dash by dy, x squared y double dash by d into d minus 1y, x cube y triple dash, and so on. So here also we will take that let z is equal to log x. Let us make a transformation. Z is equal to log x, or x is equal to e to the power z, and highlight here that now whenever I will write capital D, it will stands for d by dz. So the expression, the above equation reduces to what? X square y double dash, so it will become d into d minus 1 y minus 2y, and there is no y dash term here, and then it will be 2 x is e to the power z and plus 6, right? So this expression becomes what? This expression becomes d square minus d minus 2 y is equal to 2 e to the power z plus 6. Now we know how to solve it, so let us proceed. Change the color also. So the general solution will be written as y is equal to the complementary function part plus particular integral part. And what will be the auxiliary equation? The auxiliary equation is m square minus m minus 2 is equal to 0. So this is like m square minus 2m plus m minus 2 is equal to 0. So I can take m common, I will write m minus 2. I can take 1 common, I will write m minus 2 is equal to 0. So I will write what? I will write m minus 2 into m plus 1 is equal to 0. Yes or no? So m is equal to 2 and minus 1. So the complementary function, can anyone write directly? c1 e to the power 2z. I am writing it c1 e to the power 2z, c2 e to the power minus z. So if I continue here on this side, it will be equal to what? c1 e to the power 2z means c1 x square and plus c2 by x. So this is my CF part. Now we have to find the PI part. So PI part is 1 by d square minus d minus 2, and that we have to operate on 2 e to the power z plus 6. Right. Now we know if I know that do the direct substitution, it will not be 0, so I can do it. I can write 2 1 by in place of I am operating on this only, so I will be writing 1 square, that is 1 minus 2 e over e to the power z, and plus 1 by d square minus d minus 2, and 6 can also be seen as 6 e to the power 0z. This is a standard practice that if we can write this expression as e to the power 0z, we can apply the results easily. So here this 1 and minus 1 cancel, this is minus 2 and 2, so I will get minus e to the power z. And here if I write d is equal to 0, I will get 0 minus 2, e to the power 0z is 1, so I will get just 6. So I got what? I got e to the power minus e to the power z, and this will be like minus 3. So minus x and minus 3. So what is the general solution? Y is equal to c1 x square plus c2 by x minus 3. I hope the things are very clear to you and you have understood the process. For more problem solving or to get more confidence, you need to solve more problem. But I hope up to this it is very clear. So that's all in this video. I have solved the 6 problems. I discussed the process that how the Euler-Cauchy form can be reduced to the linear differential equation with constant coefficient, and once it is reduced to the linear differential equation with constant coefficient, we can solve it by any method. In my previous videos I already have discussed operator method, method of undetermined coefficient, method of variation of parameter. So please like the videos, share with everyone, and it is very important because for me, how do I get the motivation? The motivation comes if I feel that people are watching the video, and if I am putting some effort, it is resulting into certain positive outcome. So that's all. Thanks for watching and have a very great day.